Let's look at this problem. Solve each polynomial inequality. When I look at this problem, I see parentheses. This tells me that the factoring has already been started and it's actually already been finished. So I see that these have been factored. Maybe this was a polynomial prior to this, but they have factored for us. So when you see parentheses, that's a good thing. The factoring has already been completed for you. So to find your critical numbers, you just will take each one of these, set them equal to 0, and solve for x. So subtract 1 from both sides, x equals -1. Subtract 2 from both sides, x equals -2. And subtract 3 from both sides, x equals -3. Okay, so my critical numbers, think of your number line. Your critical numbers, you have -3, furthest to the left, -2, and -1. So those are the numbers that we have on our number line that will divide our number line into 1, 2, 3, 4 separate intervals. Notice our original problem is greater than or equal to 0, so we're looking for positive intervals. Okay, so these are the three. This time I have, this is my final factored form. I have x plus 1, x plus 2, and x plus 3. So I will have to plug in my test numbers to 3 different binomials. So a number here that I'm going to test is -4. A number here that I'm going to test would be like -2.5. This is a test number. In between here, -1.5, test number. And a number greater than -1, let's use 0. So remember, I always put my critical numbers in squares and my test numbers in circles. When you name your final answer, you only use your critical numbers. You never use test numbers. And the reason being is because everyone can use different test numbers, but we all should get the same critical number. So let's begin plugging in. If you plug in -4 plus 1, -4 plus 1 would be negative. Plugging in -4 plus 2, you get -2. That's negative. Plugging in -4 here, -4 plus 3, that's negative. Now, look at your original problem. All of these are multiplied together. So a negative times a negative gives you a positive, and a positive times that third negative gives you a negative interval. Is that what we want? No, we're looking for positive intervals. So this interval will not be included in my final answer. Now let's plug in -2.5 into all 3 of these. -2.5 plus 1 would be -1.5. Plugging in -0.5 plus 2, well, that would be -0.5, so that's negative again. Plugging in -2.5 plus 3, well, that would be positive 0.5. So now let's multiply all these together. A negative times a negative is a positive. Positive times a positive. This interval gives me a positive. Therefore, I'm going to go ahead and shade because this is part of my answer. Remember, if one number satisfies this region or this interval, every number inside this interval satisfies the solution of positive intervals. All right, let's test -1.5. Plugging in -1.5 plus 1, I get negative. -1.5 plus 2, I get positive 1.5. Use your calculator. -1.5 plus 3 would be positive 1.5, so I get a positive. Let's multiply these together. A negative times a positive gives me a negative, and a negative times a positive gives me a negative for this region. We don't want negative intervals, we want positive intervals, so I'm going to cross out that region. And finally, testing 0, our last interval. 0 plus 1 is positive. 0 plus 2 is positive. 0 plus 3 is positive 3. Now multiply all these together. A positive times a positive is a positive, and positive times a positive tells me this entire region is positive. Therefore, this interval, everything greater than -1, will be in my final answer. So let's graph our final answer. Here's -3, here's -2, and here's negative 1. Now your original problem does have the equal to, so I will be using brackets. Let's shade everything in between negative 3 and negative 2 with brackets. And let's shade in negative 1 with a bracket and everything to the right. So this would be my answer or a graph of my final answer. For interval notation, let's name our final graph. For interval notation, it would be from negative 3 to negative 2, or you could put a U, and then it would be negative 1 to positive infinity. So this would be interval notation. Like I say, instead of an or, they may want you to put a U in the online homework. So that's your final answer for that problem. Next, let's look at this problem here. Same instructions. Solve each polynomial inequality. To solve a polynomial inequality, what you want to do is to factor first. Well, like the previous problem, it already had parentheses, so it had already been factored. But with this problem, I don't see any parentheses, so we need to factor. The first step of every factoring problem is to take out a GCF. So I need to take out an x. If I go through and divide each one by x, let's leave what's inside the parentheses. I bring down the 3, x squared divided by x1 leaves x, minus, here your x's cancel, leaving 5. Now what we must do is we must take each one of these and set them equal to 0 to find our critical numbers. So let's add 5 to both sides. 3x equals to 5. Divide both sides by 3. So your two critical numbers are 0 and 5/3. Now, the original problem is less than or equal to. So we are looking for negative intervals. All right. So let's use our number line. And let's put the two critical numbers on the number line. Well, here's 0. Now, 5/3. You can punch that in your calculator, 5 divided by 3, and it would be something like 1.666 with a bar over 6, because this is really 1 2/3, and 2/3 is 0.666. So we're somewhere in between 1 and 2. So possibly maybe somewhere right here. This is 5/3. So here's my two critical numbers, 0 and 5/3. So let's pick some test intervals, or test numbers, excuse me. I'm going to separate it into intervals. I'm going to pick a test number of negative 1. I'm going to use my 1 in between for a test number in the middle region, and I'm going to use 2, a number to the right. You always go back to the final factored form right here. We'll plug it into x and 3x minus 5. Those are the two that we will substitute the test numbers into to test each interval. Testing the GCF, because it has an x, we plug it into x, and then the binomial. Always use the final factored form. So plugging in negative 1 in for x, that's negative. Negative 1 times 3, that's negative 3. Minus 5 gives me negative. Well, what's a negative times a negative? A positive. Do we want a positive interval? No. Our problem told us we want less than or equal to 0. That's negative. So I'm going to cross out that region. That is not one of my final answers. So let's test the middle interval here. I'm going to use the test number 1. Plugging in 1. 1 in for x is positive. Plugging in 1 here, 3 times 1 is 3. Minus 5 would give me negative 2. So that gives me a negative. So what's a positive times a negative? A negative. This whole interval is negative. Therefore, it is part of my final answer. Okay? Now let's test the region to the right. Plugging in 2, positive. 2 in for x is positive. Plugging in 2 here. 3 times 2 is 6. 6 minus 5 is also positive. So what's a positive times a positive? I get a positive region or positive interval. That is not what I want. I do not want positives. I want negatives. So my final answer will be in between 0 and 5/3. We'll shade everything in between. I will use a bracket because my original problem does have the equal to. If it was just plain old less than, we would use parentheses. For interval notation, your answer would be 0 5/3. 0 5/3. That would be your interval notation answer if you were asked to write it in interval notation.